Hello, everyone, and welcome to Science Explosion. My name is Zach, and I am coming at you from Hudson Public Library. For anybody not in our town, that is in Hudson, Iowa. All right, so today we're going to be talking about fire. So let's get started. So just a word of caution here. Whenever you are dealing with something like fire, you want to be safe. So if you're following along with me on this one and you are a younger viewer, then I would definitely encourage you to follow along with an adult. We are doing an experiment with fire, but you never want to play with fire. So always be safe. I also have some water on hand. This is my water bottle, so I'll be drinking out of this too. Just in case we need to put the fire out. So you just always want to be safe with that. So with that housekeeping out of the way, let's get started on this. So let's talk about what the basics are. So fire. I've got a lighter right here, and it is, first of all, I think lighters are like this are interestingly designed because you have to hit two different things for it to work. You have to click off the safety and then do that, and you've got the flame. So how does this work? This has a fuel source in the back here, and then it creates a spark, and that is fed into the flame in here. So when you know how that works, that makes it a little bit easier to understand what fire is and what it needs to have to exist. So I'm just going to go ahead, and you might have already noticed that I've got a candle right in front of me. I'm going to get that lit. New candle, so it might take a second. There we go. Look at that. I'm going to laugh if I end up accidentally blowing it out. That is definitely a possibility. All right, so fire needs three things to work. So those three things, they are oxygen, which is pretty easy to understand. That is, the air around us always has oxygen in it. If it didn't, you would be having a pretty hard time breathing right now. But it also needs fuel, and the fuel in this gets fed into it on this candle right here. So there's oxygen for all of this. So the oxygen isn't going to be a limiting thing for this. The fuel, though, that is going to be that rope and the wax right there. And then it needs heat energy. So it needs heat, fuel, and oxygen. So if it has those three things, every fire, no matter where, needs to have those three things to function. So all you have to do to put out a fire is to take one of those away. And we are going to put on our junior firefighter hats. I can't believe that this thing almost fits me, not quite, but it does kind of. So we have these at the library. I think we just have like one or two left, by the way, from a different program. Because we're going to be talking about how to put out a fire. So fuel is something that's flammable, something that can catch fire. Now, different things are going to be harder or easier to put out or to catch on fire. And it takes different temperatures for those. So that's the other part. So you can always vision this as a triangle. On one point, there is the fuel. On another point, there's the oxygen. And then on a third point, there's the heat. Now, you can start a fire with just, so this is starting it from a spark in here, but you can actually just start a fire just if you get the right amount of heat. So, all of my literary fans out there, do you know what temperature paper catches on fire? And I say literary fans because it's literally the title of a book. That's my hint to you. All right, if you didn't already know, that is Ray Bradbury's Fahrenheit 451. So that is the temperature that paper catches on fire is 451 degrees. It will spontaneously catch on fire if it gets to that much. So don't put paper in your oven because it can get that hot. And then the paper itself is the fuel, and then there's oxygen around it. So just remember, it's those three things. And I'm saying this a few times just so that people remember, because out of any of my science explosions, this is the one that could save your life. All right, so I'm going to demonstrate to you how this actually works. So the triangle in here, if we wanted to put out this fire, I wouldn't be able to demonstrate this to you very well, but you need to take away one of those three things. And the one I was saying I wouldn't be able to demonstrate very well, heat is one of those. So if I were to put this in the freezer, even though it's got enough of the fuel and the oxygen, I might end up using up the oxygen. It could go out if you get it to a low enough temperature. That's not a very good way to put out a fire though. So there's a couple better ones. So let's see. Could have done this earlier. Now this is a little bit porous, so this might not work. But one of the easiest ways to put out a fire is, actually this is fairly large, so that might take a while for that to happen. All right, but you can kind of notice it's dying down. So I'm going to be putting out this fire in one of the easier ways. I put this jar over the top of it. Oh, yep, it's going there. And so you might notice that this jar is starting to steam up. And look at that, the fire is now out. So I took away one corner of that triangle. I took away the oxygen. And you might be thinking to yourself, well, Zach, you didn't look like you took anything away from it. And I didn't really. What I did is I made this enclosed space. So what happened is that it used all of the oxygen in this jar. So actually, this is really interesting. Around you all the time, there's oxygen. In this jar right now, there's probably a small amount of oxygen still in there, but it's not enough for it to supply this with fuel. So it's virtually no oxygen in there. Now I'm going to take it out because it's completely out right now. But here's the thing. If I were to take this, woo, that smells like smoke now. Oh yeah, this whole jar does. So if I were to have this jar on there and the fire was about to go out and then I lifted it out before it went completely out, that would catch back on fire. It would light back up because now it has oxygen. I am a complete triangle again. So that is why if you ever talk to some firefighters, if there is a fire in a part of a house or a building and a door gets opened, that's letting new oxygen get in. So more oxygen means more flame. All right, so this is a basic lighter. I would not be able to light this underwater. And that is actually because this doesn't have a very hot heat. Now there are special torches that you can light and they do work underwater. They are actually hot enough that they separate the water into its key components. So it separates it into hydrogen, which is flammable, and oxygen, which is another part of the triangle. So you've got the high heat plus the oxygen plus the fuel, which is the hydrogen, and that is enough to start a fire underwater. If you have not seen those, I would recommend looking them up online. They're pretty cool. They burn very bright. All right, so that's one way. You can take away the oxygen, or probably the more boring way to put out this fire would be to wait for the candle to melt and go all the way through the candle. Now, we're not going to do that on this video because that would take quite a long time, but what would that be? What part of the triangle would that take away? What do you think? All right, so if you said the fuel, you are exactly right. So if I were to let this candle completely burn out, that's because it's used all of its fuel. So there's the basics. Now I'm going to show you the fun way to put out this candle. All right. if you want to follow along with this part, you only need a few simple ingredients. You need a flame. I would recommend doing a candle. You want something small and easy to control. You need a jar, same one I already have. You need vinegar. Just ordinary white vinegar works well. And you need baking soda. And then I've also got a spoon to scoop this with. This is left over from a different experiment, which is why I just have baking soda in a bag. All right, so what you're going to do is you are going to pour your vinegar, depending on the size of the jar, about 1/3 to 1/2 of the way up. All right, and who knows what happens when you mix baking soda with vinegar. The reason you don't want to fill this up, you're going to see in just a second. So then you're going to take a spoonful of baking soda. Try to make it a heaping spoonful. Drop it in. Watch that fizz. That is why you don't fill it up all the way, because if you overfill this, it's going to spill out. Wait for it to fizz down a bit. All right, so baking soda, when you put it in to vinegar, you are causing a chemical reaction, and that is producing carbon dioxide, which is carbon connected to oxygen. I'm going to wait for it to stop fizzing just a little bit more. You don't want to wait too long. All right. That smell of vinegar, pretty hard to miss. All right, let's see. So now you're going to pour from this part, not the liquid, onto your flame. Let's see if this works. So I saw it flicker, but I don't think I put enough of this in. Or I waited a little too long. I might have waited a little too long. So let's try this again. There you go. Putting a little more baking soda. Look at that, just the right amount where it's not spilling over the side. Oh, never mind, it is spilling over the side. Let's see here. Still should work decently well here for me. There we go. All right, did you see that? So, if you missed that, I'm going to do it one more time. All right, let's get this going again. All right, so I'm going to leave this in the video so that you can hypothesize, what did I do wrong the first time? I've got a pretty good idea of what I did wrong. I hinted at it just a little bit. All right, so I don't have a very strong flame there, but it's going. I think you can see it. I'm going to fix that just a little bit here. It's going to go out while I do this, but I'm moving the wick so it'll stand up. No, like that again. There we go. That's a much stronger flame. I'm going to get a new spoon because this one got vinegar on it because I put too much in there. Helps me that I have them right behind me. All right, so you're going to grab your spoon. I think it should still be fine with that amount of vinegar. There's still plenty that'll be able to react to this. I'm going to get my spoon, put it in there. It's going to fizz up again. Not nearly as much fizz this time because a lot of the vinegar has already reacted to the baking soda. And while that's going, I'm going to pour. And you see that? No liquid came out, only gas. All right, so what happened? Why did this flame go out? What do you think? All right, so remember the triangle of what you have. You need fuel, which it's still got that fuel. The candle is the fuel and it hasn't gone anywhere. You've got the heat energy. It's plenty hot. The flame isn't getting colder. I'm not making it colder with this liquid, which is going to be a little bit colder than room temperature. But what I am doing is I'm cutting it off from its source of oxygen. So when you put vinegar with baking soda, it produces carbon dioxide. So produces, if you don't know, it means that it makes that. That's the product. So when I am pouring this out, you might be asking, why am I able to pour a gas? You might be thinking to yourself, well, Zach, don't gases expand? Because if I remember right, a solid is something that keeps its shape, a liquid is something that can move around, and a gas is something that expands to fill its container. And put simply, yes, that's completely true. You are exactly right if that's what you're thinking. But think about this. I want you to picture a helium balloon. And what's it do? So if you put helium in a balloon, that balloon is going to float. And that's because helium is lighter than air. Now, carbon dioxide, you might be already ahead of me on where I'm going on this. Carbon dioxide is heavier than air. And so when it produces that carbon dioxide in here, it stays in the jar. So it hasn't had the chance to get absorbed by the rest of the air. So it gets produced and then it sinks down into this jar. Now, if it was lighter than air, it would go out of the jar right away. So if I had a reaction that made helium, it would go out almost instantly. But the fact that it's heavier than air means it's staying in this jar. So when I go to pour it, even though I'm not pouring a liquid, I'm pouring a gas, I still am pouring a gas. So you can't see it, it's invisible to us. But a gas, when I pour this, is pouring out of this container. It's carbon dioxide that is pouring. And remember, it's heavier, so it's going to fall out of this, just like if I was pouring a liquid onto that. So this is a pretty easy experiment, one that you can easily do yourself. And I would definitely encourage you to take a look at that and do this yourself. All right, so there's a point to this too, beyond just, I think it's kind of fun to say that you're pouring a gas, because that's not something you really get to do much in your life. But also, this is basically the way that fire extinguishers work. So fire extinguishers are going to produce a chemical reaction a lot like this one to create a chemical that smothers something. So that's exactly what's happened in this one. And now you might be thinking, well, Zach, you still haven't done the most common way of blowing out a candle. And yes, I will do that right now just to make you happy there. So blowing out a candle is probably the most common way to put it out. And that is actually going to do a very similar thing. That's going to be cutting it off from oxygen. Now, here's the thing. You do have oxygen in your breath, but it is going to be overwhelming this and cutting it off from its fuel source. So the way the fire extinguishers work, if you haven't actually had the chance to use a fire extinguisher before, that's probably a good thing. You don't want to actually have to use a fire extinguisher to put out a fire. Now, I will say I have on multiple occasions used a fire extinguisher, but that's because I've taken classes on fire safety. And if you ever get the chance to do that, I would recommend signing up to do one of those. It is a different experience when you actually get to pull the trigger on a fire extinguisher yourself. And if you haven't, I'm just going to also say the one thing of remember always to aim at the base of the fire. So we're talking about fire here, and you can't quite tell with the way I'm pouring it on this because this is smothering it from above. But the best way to get this fire gone isn't from the top, because that's just the top part of the fire. It's going to be at the bottom where it reaches that, so you can cut it off from its fuel a lot better. All right. By the way, so we talked about gases rising and falling based on how dense they are. And obviously, the liquid is always going to be more dense than the gas. And that's why it's going to stay at the bottom of this jar instead of floating up out. So speaking of climbing and lowering, fire always climbs. So that's why fire can work when you have it like this. It's going to, there we go. It is going to try to rise. So if I were to put something above this fire, if I were to light this and then put a piece of paper here, the fire would jump to that piece of paper and keep climbing up. But if I were to light this here and then have paper down here, unless a spark falls off of this, the fire isn't going to go there. So I just think some good things to know. All right. So in summary for that, you've got the triangle where you've got the heat, fuel, and oxygen. Those are the three things, and you just need to take one of those away to get rid of a fire. And a fire just basically is a chemical reaction that is causing the rapid oxidization of something. All right, so what does that mean? So oxidization is a long word, but all it really means is reacting with oxygen. So it is the rapid reacting with oxygen, and it's turning things rapidly into a gas. So you might not actually know that's what's happening with this fire right now. So if you remember, or you might not know, this might be a new concept to you, but in physics, a very important concept is that matter cannot be created or destroyed. So this wick right here and this candle, it's not going away. It's still here, but in a different form. So this fire, what's happening when it's burning is it's actually turning the material that was a wick into gases. And now those gases are filling this room. And so that's also a big part of what smoke is. So smoke is those things being turned into gases, but also particles are in smoke. All right, so I know that might seem a little bit complicated to some people, but I think that's a really good thing to know of that's actually what's happening in fire. It's turning things into a gas. Now, if you remember, if you've talked to me before or watched one of my other videos about states of matter, then you might already know that there's solid, liquids, and gas, and those really have to do with how much motion the atoms inside of those have. And so what's happening here, it's a solid, and this is turning it rapidly, so quickly, into a gas. It's taking those atoms and it's causing them to rapidly move against each other, and then they can spread out when they're in a gas form. So I think the more you know about a subject, the easier it is to solve the problems with this. And fire is a big problem. You might know, or you might even be in the American West right now, and there have been lots of fires. There have been fires earlier this year as well in places like Australia. So wildfires can actually be a big problem. So part of the way that scientists are solving that problem is you really need to know how to solve it by understanding what the problem itself is. All right, so I think this is a pretty easy experiment, pretty simple to do, but I think it really makes the point of that is how fire works, and that's how you can stop it from working. All right, so thank you everyone so much for joining me. This has been Science Explosion with Zach at Hudson Public Library. And next week, we are going to be talking about flying and floating. Thank you very much. Bye.